Generalizations about multiplying fractions. Hi, fifth grade. Today we are going to be making generalizations when multiplying fractions. In order to do that, well, one, we need to know what a generalization is. Do you know what a generalization is? Let's break apart this word. It's for sure what part of speech? Hopefully you said noun. Yeah, who would have thought we can incorporate some ELA in math, but we're doing it, right? It is a noun. And general. General, basic, common. Generalization. I'll tell you, a generalization is a broad statement or an idea that applies to a lot of situations. So we're going to look at some fraction multiplication equations today and think about some patterns we can find. Let's take a look. Okay, take a look at these problems here. I want you to pause the video and I want you to think about the following things. Number one, do you notice any patterns when you're looking at these equations? Next, I want you to think about what the equations have in common. And finally, how are the fractions being multiplied related to their products? Let's take a look at this clean copy. Go ahead and pause the video here and think about one more time. Do you notice any patterns? Jot them down on your notes. What do the equations have in common? And how are the fractions being multiplied related to their products? Remember, a product is the answer to a multiplication equation. Something I noticed is that all of the products are less than 1. I also noticed that all of the fractions are factors that are less than 1. I think we should make a chart. What do you think? Put this heading on your paper, Generalizations about multiplying fractions. Okay, let's also write down that all of the products are less than 1. When looking back at these, you notice that every single one of these products or answers is less than 1. The next thing to notice is that you can multiply the numerators and denominators, and that's going to give you the product. Let's take a look at the problem 1/2 times 2/3 and think about how when we multiply the numerators and denominators, we get the product. If I multiply the numerators, 1 times 2, and then the denominators, 2 times 3, we end up with 2/6. Now, this is not simplified, so let's make it simplified. Hopefully you already figured out this should be 1/3. So, all in all, we figured out that making generalizations about multiplying fractions, the products are less than 1, and then you can multiply the numerators and denominators, and that gives you the product. And finally, the product is less than both of the fractions being multiplied. Notice here, 1/2 is greater than 1/3, and 2/3 is greater than 1/3. Let's see if these generalizations follow when you're multiplying a fraction by a whole number or a fraction by a mixed number. Go ahead and pause the video here and write these 3 problems down with the headings above. Let's solve these together and think about more generalizations. Okay, we spent a lot of time multiplying fractions by fractions, and we used a model where we would draw the area model to determine the product. So this time I'd like you to consider, now we have a whole number here instead of a fraction. So if we're able to multiply numerators by numerators and denominators by denominators, we can essentially find out how to solve this problem. The other thing that we can do, when you have a whole number and a fraction, you know when you're multiplying 3/4 by 2 that you have 3/4 2 times, right? Remember, we use repeated addition also to multiply. So if we just have a whole number like this, it's very easy to say 3/4 is the same as 3/4 plus 3/4, which would give you 6/4, right? Now, because this is an improper fraction, remember an improper fraction is where the numerator is greater than the denominator. We want to go ahead and we want to make this a mixed number. So let's take a look. We have 6/4. So think here, how many wholes does 6/4 make? So if we know that this piece, this whole would be 4/4, we definitely have one of those, right? So we have one. And if we had 4/4 to make 1, then 2 would be left over, right? Because to go from 4 to 2 would be 2/4. And 1 and 2/4 is the same as 1 and 1/2. Okay, does that make sense? Now, the other way to do this without showing all of these steps, which are very important because we always want to show our work, is by saying 2 times 3, okay, which would give you 6. That would give you how many fourths there would be, right? Okay, so here's one way. What do you notice though? Let's relate these factors. So we have a factor of 3/4 and a factor of 2. Let's relate them to our product. Okay, so let's look for some patterns. So as you can see, 1 and 1/2 is less than the whole number, right? It's less than the whole number. And 3/4 is less than the product. So the product is greater than the fraction factor, but it is less than the whole number factor, okay? I wonder if this is true for all problems. Let's try one more. What if we did 2/3 times 2? 2/3 times 2. Let's do the same thing, except this time, instead of writing repeated addition, so that would be 2/3 and 2/3 again, let's just multiply. So we have 2 times 2, which would be 4/3, right? 2 times 2/3, 4/3, okay? And 4/3 is the same as how many wholes, right? So if a whole is 3/3, that would be 1, and there would be 1 left over, 1 and 1/3, okay? Any noticings? Does it follow the same generalization or rule rather? 1 and 1/3 is less than the whole number factor. Okay, and 1 and 1/3 is also greater than the fraction factor, just like in this problem up here. So that's another generalization you can make. And it's also a great thing to think about and consider when you're solving problems like this. Okay, so the product is greater than the fraction factor. And the product is going to be less than the whole number. So greater than the fraction factor and less than the whole number factor. We should probably say factor. Okay? Now let's see if these above generalizations here will work for mixed numbers too. Now remember, a mixed number is already greater than a whole, right? So we have our fractions and mixed numbers. Now, before we can multiply these, as we did previously, we used a model, and we'll continue to use those models, but let's also make sure we have a procedure down that works. When we're multiplying 1/3 times 1 and 1/3, we want to think of 1 and 1/3 as it would be a fraction. So we're going to want to make it a an improper fraction. So we're going to turn it from an mixed number to an improper fraction. So let's go ahead and do that. In order to do that, we need to look at the equation a little differently. So we have 1/3, and then we're going to multiply it by 1 and 1/3, which is the same as, now there's two ways to do this. How I do it is I always look at the fraction part of my mixed number and say, okay, this is out of thirds, and I have one whole, which would be 3/3, and a third, which makes 4/3, right? Now there's also what I'd like to call maybe just a little trick that I learned when I was learning how to originally turn a mixed number to a improper fraction, is you'll multiply the whole number by the denominator, so 1 times 3, and then you add the numerator. So 1 times 3 plus 1 is 4. So we got 4. And this is broken up into thirds, so the denominator will always stay the same. Now, the rules for multiplying are going to be just like when you multiply a fraction by a fraction, because you have two fractions here, right? So 1 times 4 is 4, and 3 times 3 is 9, okay? And you have 4/9, and this is already simplified. Now, do the rules still apply? Well, let's take a look. Okay, is the product less than the whole number factor or the mixed number factor? Yes, it is, because this isn't even a whole, right? Is the product greater than the fraction factor? Well, in order to know that for certain, we might want to turn this into or think of this factor as an equivalent fraction. So this is an easy one because I know that 1/3 is the same as 3/9, right? Because 1 times 3 is 3, 3 times 3 is 9, right? So 3/9 is in fact less than 4/9. So that would mean, yes, it's true that the product is greater than the fraction factor. Let's do one more and see if this still works. Okay, now we have 2/3 times 1 1/2. So let's take a look at that here. We're gonna rewrite the problem just like last time, right? We can work this one out together. 1 1/2 is the same as, so 2 halves plus 1 would be 3 halves, right? So 2/3 times 3 halves, and that would equal 6/6. Ooh. Which equals 1. Okay, let's check this out. Is the product greater than the fraction factor? Let's see. 1 is definitely greater than 2/3, right? Let's check this. Is the product less than, so smaller than the whole number factor, or in this case, the mixed number factor? It sure is. So, do these generalizations work? They sure do. Now, why don't you go ahead and solve this one for me, and let's just check and make sure you did it right. Did you get 6/12 or 1/2? If you did, great job. I want to see that smiley face on your notes when you take a picture too. Okay, so here's the generalizations. When you're multiplying a fraction by a fraction, the product is always going to be less than 1. And the product is also going to be less than both of the fractions being multiplied. All right? And then when we consider multiplying fractions by whole or mixed numbers, we always want to remember that the product's going to be greater than the fraction factor, and the product's going to be less than the whole or the mixed number factor. Now let's practice using some of that information to do some independent work.